Okay, so now we'll look how to work with these a bit algebraically with 3u plus v dotted with the dot product of 2u minus v. And again, when you're done this, you should end up with a scalar for the whole thing, okay? So let's take a look at, first of all, you've got u and v, and these are unit vectors. So that means that the magnitude of u is equal to 1, and the magnitude of v is also equal to 1. Okay, so that's what unit vectors mean. And then there, 60 degrees is the angle between the two. Okay, so we've got that, and that's what our theta equals. Okay, and now we can take a look at how we work with these algebraically. So 3u plus v, dotted with 2u minus v. Okay, we work with them the same way we would do the foiling type of idea, except we don't do this. So this, we do 3u dotted with 2u. Remember, so my the coefficients or the scalars that we're multiplying, we can just multiply those straightforward, so we get 6 in there for that. Okay, and then once we have the 6, we don't do this, so we can't square that like that. Okay, that doesn't happen with this. What you're doing is the dot product of the two. So what you would have is u dotted with u. Okay, and then we can move on and we'll do negative 3 u dotted with v. Okay, and then we'll have a plus 2u dotted with v. Okay, and then we have a positive 1 and a negative 1, so those scalars will give us a negative 1, and then v dotted with v. Okay. From the property that we learned previously here, so 6, the u dotted with u, remember the angle is 0 between these, so we end up with the magnitude of u squared. The negative 3u and the positive 2uv, we can take those as almost like terms. So it's a negative u dotted with v, and then a negative magnitude of v all squared. Okay, that'll give us, since the magnitude of u is 1, we'll have 1 squared minus u dotted with v and minus a 1 squared again. Okay, that'll give us 5 minus u dotted with v. Okay, I'm just going to move over the page, so just hold on a sec. Okay, so we'll just move this up here, just make some room here, and we'll take up, so we ended up with, it's 5 minus a u dotted with v, and now we can do our 5 minus the magnitude of u, magnitude of v, and cos of 60. Okay, so we didn't really have to do much in terms of actually getting the dot products before and using the angles, because everything was kind of set up that the magnitude of the same vectors, or the dot product of the same vectors, just gave us the magnitude squared, and cos of 60 is a half, and we'll end up with 4.5. Okay, and again, for now, just get used to how the formulas work, and we'll see how we apply them and what they mean. But just keep in mind that we're always finding that horizontal component of one vector, and we're multiplying that with just the vector itself that runs parallel to that horizontal component, okay? So now we'll look at them algebraically and how that works, okay? Okay, so when we look at these vectors in the Cartesian vectors, okay, and how we're doing this, this is really your x value here and your y value that we're multiplying, and then your x value and your y value, okay? So this will be x1 and y1, x2 and y2, so we have those components there. And we're going to multiply the x1 times the x2 and plus the y1 times the y2. Okay, so we're just multiplying our horizontal components and multiplying our vertical components and then adding them together, and that'll give us the dot product algebraically. Okay, so here's an example. So u dotted with v is equal to, they're given to us, the two vectors, so 3, -2, dotted with 4 and -2. Okay, so take your horizontal components, so we'll end up with 3 times 4 plus a -2 times a -2. Okay, so again, we're taking the 3 and the 4, that's the product there, and then -2 and -2 is here, and then we take the sum of the two. Okay, so that'll give us the 12 plus the 4, which gives us 16, and units, whatever the units are in this case. Okay, so but we're again a scalar out of the dot product. Okay, so that's example 3, and we'll move on to the next one. Okay, so we want to find now, whenever you see the word perpendicular with vectors, you should automatically be thinking dot product should equal 0. Okay, so we want to find the dot product u dotted with some other vector v should equal 0. Okay, they're given, u is given to us, so we can write it down as 3 comma -2 dotted with some vector a and b. Okay, and we don't know what those are right now. Now we can rearrange this. We can work with this and do the dot product with it first. So 3a and 3 times a, and then -2 times b will give us the -2b is equal to 0. The 3a will equal 2b, and my a value then is equal to 2/3 of b. Okay, so one thing I want to kind of make clear here, if I have the vector u, so if we do a diagram here, so just so you understand why we can pick any value here, we can have so many different vectors. So 3, -2, 3 on the x, -2 on the y, so it's down here somewhere. Let's call that 3, let's call that -2. Okay, so there's my vector there. And if I want to get something that's perpendicular to that, well, there's so many. That's perpendicular. That's perpendicular. Okay, that's perpendicular. And they can be as long as they want to be. I could have made that twice as long, right? So there's an infinite amount of vectors that I can do, that I can find, that will be perpendicular to u. But what I want is an easy one to be. So I can, when I have something set up like this, if I let b equal 3, that's the easiest one because it'll just cancel out my denominator there. So if we set this up now, remember we have a is equal to 2/3 of b. I let b equal 3, so a is equal to 2/3 times 3, where the 3's cancel, and I get a is equal to 2. So now I have my two values, a and b. And I could have made b 5 if I wanted to, and I would have got 10/3 for a. It's still perpendicular to it. I could have made it b 12, and I would have got a is 8, and it still would have been perpendicular to it. Okay, so you could have picked any value, but 3 here made the most sense because it keeps it the simplest. Okay. Okay, Okay, so I just moved over the page here a bit. So therefore, we can say a vector perpendicular to U is 2, 3. Okay, and you could check. Obviously, you can check that if I did 2, 3. So just say check 2, 3, and dotted with 3, -2, which was our original vector. That gives us 6, and 2 times 3 is 6, and then -6, which also gives us 0, and therefore we have perpendicular vectors. Okay, so there's an infinite amount of vectors that could have been picked here, but in this case, try to pick the easiest one to do that with. Okay.